Hi, this is Phil, welcoming you to part 3, where I shall be getting stuck into phase 2 of this Ekco AD75 radio refurbishment. It will include rebuilding the IF amplifier, as well as rebuilding the bandpass filters, the frequency changer and local oscillator circuits. Hopefully I will be able to power up this radio chassis, and with a bit of good fortune I might get it to work. We shall see. In this episode, the area of this radio circuit where I'll resume will be just here, pertaining to the IF amplifier, which in this instance incorporates the venerable EF39 Very IF amplifier pentode valve. I'm quite surprised how long it has took me to complete wiring in this IF amplifier circuitry. I've also cleaned and fitted the first IF transformer onto this chassis, but it is not as yet connected. That is to be part of my next phase in this restoration project. I'm already ahead in that respect since I've cleaned the local oscillator canister. My next part of that task is to solder replacement lengths of wire onto each winding terminal pairs along this wooden dowel, which fits inside that local oscillator canister. Before doing that, I'll move over to my laptop so you can see, with respect to this radio circuit, where I'm at thus so far into this restoration project. You will recall I progressed as far as this point along the HT rail after I'd wired in the rectifier V4 and audio output valve V3 circuitries. The final part of that particular phase was wiring in this bifilter circuit. The second phase began with wiring in the components pertaining to V2 EF39 IF amplifier Very pentode valve, which included connecting IF tank circuit, L10 and C35 trimmer capacitor, R7 2.2K carbon resistor, C12 100 nanofarad decoupling capacitor. I then went on to connect R8 91K carbon resistor, which goes to grid 2 of V2, and decoupling capacitor C13 100 nanofarad down to deck. My final part was to connect from grid 3 and cathode R9 330 ohms in parallel with C14 22 nanofarad down to deck. The reason I went on to clean and fit IFT1, grid 1 of V2, which is via the top cap, is direct out of the secondary of that tank circuit L9 and C34 trimmer capacitor. My final part of phase 2 will be to wire in the circuitry pertaining to V1 CCH35 triode hexode frequency changer valve. I'm about 1/3 of the way into phase 2. There is not a lot to see. Nonetheless, the entire wave change switch, has been rewired, and the local oscillator coils and canister have been rewired, and it is secured back onto the chassis. At present it looks to be a jumbled mess, but it will begin taking shape once I've replaced these 3 100 nanofarad capacitors and done a bit of lead dressing. Okay chaps, checking, replacing components and rewiring any vintage radio will be, by its complexity, a very long-winded operation. Accept it as normal, so always be prepared. So, what are the basic requirements before starting? Lots of planning, familiarisation of the circuit diagram, as well as the chassis layout, compiling loads of documentation, getting what you think are all the required components together beforehand, even if a percentage of them might not be required, such as resistors found to be well within their tolerance banding, having the required tools and equipment to hand, cleaning materials also to hand, such as lubricants, abrasive papers, spray paints, etc., and somewhere to place the rubbish, as there will be very likely lots of it. But above all, be very sure what you are up against, and how best to overcome the unforeseen or unexpected before undertaking these types of restoration projects. It is important this last point features somewhere very close to the top of your considerations before embarking. As I say, very important. Wiring in and checking my work for phase 2 is nearing complete. There are 3 remaining connections to be made. Right, let's see, that's local oscillator 3. That will be put in place of yep, that's local oscillator, so that will be connected onto there. That is a trimmer capacitor, that is on the top side of this chassis, and local oscillator 6. Well, there's only this one that's remaining, and that is local oscillator 6, so this will be connected onto there. And of course I will fit this grounding strap onto the frame of the tuner capacitor, and fit this double tag board onto the chassis with these 2 wire ties. And then I'm ready for a good check over. As I have said, once I have done those, I'll go on to do a thorough check and inspection of my work. It is usually good practice, in instances of this type, not to be overconfident. I've been in this game for almost 50 years, and I continue making loads of errors, especially when undertaking restoration work of this nature. And I know lots of fellow old-timers who do similar. So it is important to constantly check over your work, and if it turns out to be having no errors, then it is another feather in your cap. Right chaps, I'll do these connections, then I'll practice what I preach. Give my entire work a thorough good checking over. I've thoroughly checked my work twice against the circuit diagram, and I'm pleased to report I haven't found anything untoward. Provided the CCH35 frequency changer and the EF39 IF amplifier valves are okay, there's no reason why I shouldn't get a wee tune out of this radio. We have to take into consideration that replacing various components and disturbing the wiring will inevitably cause some deficiency of IF gain as well as oscillator tracking problems. I will, therefore, need to do a fault alignment to bring this radio's performance back up to speed. Now, there is one small, seemingly insignificant part of most vintage radios that too requires attention. That is the tuning capacitor movement and appurtenances. I've cleaned and lubricated this tuning capacitor's movement, and it now moves freely. Not that it didn't before I did all of that, but this particular model of radio incorporates a tuning reduction mechanism known as an epicyclic drive. That also requires attention. It has been soaked in paraffin for almost 2 hours to soften the old hog grease around its bearings. I could have completely stripped it, which I've done several times in past years, but I've found soaking it in paraffin and leaving it to drain for a few hours is just as effective. This wee epicyclic drive, which is a 2.5 to 1 turns ratio, has been lubricated with ordinary high temperature wheel bearing grease via this wee orifice. Always remember not to overpack with grease. It will only seep out when it is rotated, and your cleaning effort will be smearing grease. All you should aim for is free movement and stopping the 3 bearings from chattering when its spindle is rotated. Nothing more. They are straightforward to fit. Locate this wee peg into this cutaway and tighten the 2 grub screws in this fixing collar onto the tuning capacitor spindle. Now I'll go on to secure this epicyclic drive onto this tuning capacitor spindle, valve up this chassis, apply isolated mains power. I'll not do that via a variable mains transformer also, since I'm fairly confident this operation will be sufficiently safe, and we'll see if it is possible to get a wee tune out of this gem. Epicyclic drive fitted, and it rotates freely. This chassis now valved up. Note well here, though this radio will be powered up via an isolation transformer, it has to be borne in mind it is quite possible to receive a very nasty shock. One reason I fitted this radio's 3 knobs onto their respective spindles. It is not so critical as far as the volume potentiometer and on-off switch control is concerned, since it has a nylon spindle. Nonetheless, fitting the entire complement of knobs, especially where a live AC/DC chassis is concerned, is always good practice. Remember, when skin is in direct contact with bare metal, effectively you are in contact with one side of the mains or 240 volts AC isolated supply. Right chaps, a quick check over. Bench speaker connected, aerial in the appropriate orifice, chassis plugged into an isolated 240 volt bench AC supply, and switch on. And wait for the valves to warm up. Takes a bit of a time. Sure it will get there. Ah. Ah, a problem. It appears there is some type of problem here, chaps. I'm going to take Right, as I say, I'm going to take an educated guess here and say this EF39 IF amplifier valve is quite likely defective. I'll go grab a plastic container full of valves and see what there is in there. I'll return shortly. Often we come up with quick thoughts and make brash assumptions loosely based upon past experiences in the hope they will be applicable to what is before us, only to discover we have been barking up the wrong tree. None more so than me, especially when I boldly jumped to the conclusion the EF39 IF amplifier valve might be defective. Having selected a plastic container of valves from downstairs, it suddenly occurred to me, if the gain of this radio improves when I physically touch grid 1, which is the top cap of the EF39 valve, I'm making its grid less negative, therefore it passes a little more current. That strongly suggested to me there had to be an AGC problem somewhere, but I'd checked the AGC line, or rather looked it over, and found everything I'd done coincided with the circuit diagram. I supposed, having powered up this radio for the first time, given all replacement components were new and checked before being installed, and knowing its circuit was wired correct, the only item left was this valve. Having tried a couple of replacement EF39 valves that I fully expected would not cure the problem, I turned my attention directly to the AGC line. Poking around with my usual pointing stick revealed a defective new old stock capacitor that I'd checked before installation might be a possible culprit. I lightly tapped this 10 nanofarad capacitor, and this radio burst into life. Lightly tapped it again, and the fault reappeared. That capacitor has an internal intermittent connection problem. Whether I'd damaged it during installation or whether it was defective beforehand is anyone's guess, but I replaced it with one I'd bought this last January. Although this radio was working fine, I decided, purely as a precaution, to replace the replacement old new stock Plessey capacitors. I've plugged this radio into an isolated main supply, connected a speaker up to it, and plugged an aerial in, and it is now switched onto the long wave band.
I just can't believe it. For the first time in nearly 20 years, I shan't be going to bed here tonight.
There's generally not much on long wave, not like there used to be.
So whilst there is a capacity restraints in place now.
It's a 3-week break.
Neil and I fell in love after rebuilt.
Revisited is on BBC Radio 4, Sunday to Thursday evening.
Now onto the long wave band.
Those can be coloured any one of the colours or none. How many unique ways could
It would breach an agreement the Premier League and EFL have with the foot
And everything, but if you want to know, maybe I shouldn't be saying this. Maybe this is bad for national morale. Do you know what I mean? No. On Facebook, 10 albums,
Yes,
and
I've
then
seen it, yeah,
like,
yeah.
if you want to do it, brilliant, right? Good for you and all your stuff, but don't then make someone the ESL, whatever it's called, Ice Bucket Challenge, where I mean I've been nominated by other people now, and this has put my friendship in a bit of a bind.
Now you have seen and heard this radio perform, I'll return this container of valves. Here, back to its designated place. Then I'll go to my laptop so you can look once again at this radio circuit diagram and see what has been achieved and also what has been corrected. You will recall the IF amplifier circuit pertaining to the EF39 valve was wired in and good to go. All that was left to do was wire in the circuitry pertaining to V1 CCH35 frequency changer valve. I started by replacing perished rubber sheathed wires connecting to L1 together with L2 medium wave and L3 long wave, C2, which is a medium wave shunt capacitor, along with C27 and tuning capacitor C28 and trimmer capacitor C29, forming parts of the bandpass filter circuits. I also checked C1 2.2 nanofarad aerial isolation capacitor, as well as C3 100 nanofarad grid 1 blocking or decoupling capacitor. Having done all of that, it was time to turn my attention towards R2, 47k potential divider and voltage supply resistor onto grids 2 and 4 of V1, and also replace R3, 68k bottom part of the potential divider down to deck, along with C4 100 nanofarad decoupling capacitor that shunts R3. Once they were sorted out, R4 200 ohms cathode resistor measured intolerance, so I left it in circuit, but I replaced C5 100 nanofarad cathode shunt capacitor, and whilst I was on with that, I checked and replaced R5 100k screen grid resistor, wires connecting to L4 medium wave and L5 long wave, as well as L6 and L7 local oscillator reaction coils. The wires to them were also replaced. I also checked R6 47k triode anode voltage supply, which measured well within tolerance, so I left it in circuit. C10 100 nanofarad oscillator decoupling capacitor was replaced, and I didn't neglect to replace Paris sheath wires connecting to switches S3, S4 and S5, and I wired in IF transformer L8, C35, L9 and C34. The old stock, the new old stock 10 nanofarad capacitor C11 I found to be defective, as part of the AGC line forms part of the process that is a non-linear time varying signal dependent feedback system. When it was open circuit, the signal was not being regulated. C11 therefore performs a very important function within the operation of this radio's performance. Now I'll go on to do some lead dressing. As can be seen, all the replacement new old stock capacitors have been replaced with recently purchased capacitors. Not there was anything untoward with the new old stock capacitors I had fitted. I believe replacing them has put my mind at ease. Following on from replacing the replacement capacitors, I went on to do some lead dressing. There wasn't much dressing required. nonetheless, I used a multi-comp lacing cord. I'd originally bought it thinking it might be useful as a drive cord substitute, but I soon found it to be unsuitable since it easily stretches. However, it enabled me to do a reasonably decent job tidying loose, unsightly jumbled wires. Laced wires in what is now vintage radios was not often done. Being for the large part mass-produced durables, it was quicker and less expensive to route wires through fabric, rubber, or plastic flexible tubing. In instances where hum might be a factor, the wires might have been plaited rather than use shielded wire. From a personal point of view, I prefer seeing corded wires. One immediately sees someone had taken the time to produce that which is often a neat job, and it usually has a sort of professional look to the apparatus. These days, ties have largely taken over from lacing cord. I will say, ties are quicker, easy to fit, and generally more convenient, and usually do a good job. Some might argue ties do a more efficient job when compared to lacing cord, which I say is probably true in most instances. It comes down to personal preference. Righty-o, chaps. I'd say this is as good a time as any to conclude part 3. The radio chassis is looking fairly decent, and its performance, despite not being realigned, is better than I'd expected. In part 4, I'll be concentrating on appearances, not from a personal point of view, though some might say it wouldn't go amiss. I'll also do a complete realignment. Mustn't spoil the ship for a penn'orth of tar. Thank you for viewing. Your time and interest is always appreciated. If vintage radio is of interest, I invite you to join me for part 4, and to also subscribe to my channel. That is, if you haven't already done so. Until next time, it's TTFN from Phil.